All right, hello, grade 10 math students. Welcome to Unit 4. You have made it through 3 units. Good for you. The 4th unit is going to be called Quadratics. This is going to be something that you probably haven't seen before unless you've done a grade 10 class before already, or you've seen this content in other classes. I don't know. So to start it off, I'm going to be talking about quadratic patterns and how we can tell the difference between a quadratic relationship and a linear relationship. First, I just wanted to show you that I have started a new outline for this unit. So this will be put up on Brightspace. We have our learning goals here. Again, 2Ds and 2Ps, you're going to be following the same topics and using the same resources and doing the same assessments because this unit aligns for us until the very end. And we'll see if we even get to that this year. So our learning goals for this unit, you're going to be able to basically do algebra with quadratics. You're going to be able to look at characteristics of quadratic relations. This just means, can you tell the difference between linear and quadratic? And then, can I solve problems involving quadratics? And so as I make the lessons, you'll see that I'm going to fill this in and as we go along. And so this will be a nice spot for you to be able to come back to see what we're doing and what's coming up. That will be at the in the course content on Brightspace. Okay, so let's dive right in here with quadratics. You might be thinking, what in the world is a quadratic? Well, let's review first linear patterning. We've done this before, and you probably all saw this in your grade 9 classes, maybe even before. So remember when we had patterns with tiles, we could use the tiles, so the total number of tiles in each step, as a function of the step number. So this is step number 3, and you can see we have 3 green tiles and 1 yellow one. And in step number 4, we have 4 green tiles and 1 yellow. We have 5 green tiles, 1 yellow, 6 green tiles, and 1 yellow. So remember when we're coming up with an equation to model these patterns with tiles, N will tell us the total number of tiles in each position. So this one has a total of 3 plus 1 is 4. This one has a total of 5, etc. P is the position number. So this is position number 3, number 4, number 5, and number 6. And our equation looks like something. N, the total number of tiles, equals something, a number times P times the position plus something else. And the nice thing about a lot of these tile patterns is that they're color-coded sometimes, not all the time. So in this case, the green tells us that there's 3 tiles, 4, 5, 6. That's going to help us decide what number to put in here. Well, you'll notice if there's 3, it matches, 4, it matches, 5, it matches, and 6, it matches. So there's going to be 1 of the P plus an extra 1 plus a yellow each time. So the equation that models this relationship, or this pattern, sorry, is the total number of tiles equals 1 times our position number plus 1. So that makes sense. If we do 1 times 3, which is 3 plus 3, sorry, plus 1 is 4. So if we're in position 3, we have a total of 4 tiles, and that works out. So that's a linear pattern, right? Because this has the relationship in the form of y equals mx plus b. In a quadratic, we have squares involved. So this one, in position 3, notice how we have a 3 by 3 squared. And 3 times 3 is 9, which is 3 squared. And now we have plus 1. Now let's look at the next step. We have a 4 by 4 square. And if you're squaring a number, 4 squared is 4 times 4, which gives us the total number of squares in this block here. And if you count them all, that should be 16. And then we have 1. So let's think about what are the next 2 steps going to look like. Well, this is a 3 by 3 block. This is a 4 by 4 block in step 4. So in step 5, what are we going to have? Well, we're going to have a 5 by 5 block. Sorry, it doesn't look perfect, but there it is. So we have a 5 by 5 block with a total number of 25 because we have 5 rows of 5 columns. And then we have the one little yellow one on the end. Now the 6, what are we going to have in the green? Well, to follow the pattern, we're going to have a 6 by 6 block, aren't we? And if you have 6 rows and 6 columns, you have a total of 36, which is 6 squared. And then we have our one little yellow one. So if we think about an equation that models this, well, the total number of tiles is still going to be n, and the position number is still going to be p. Well, notice how we have 3 by 3, so that's 3 squared. Notice how it's in a square, so that helps us to tell that it's 3 squared plus 1. So it's going to be position number squared plus 1. So our equation is going to be, let me move that out of the way so you can see that. The equation is going to be the total number of tiles is equal to the position number squared plus an additional tile. And that works for these, right? So if we do 4 times 4, because that's 4 squared, is 16 plus 1 would give us 17. And then if you counted the number of tiles, you would get 17. And same if you continued on. So the difference here, if we just look at the equations, the difference between a linear relationship is it follows y equals mx plus b. A quadratic relationship has a squared on the variable. Okay, so that's one of the big differences, and we're going to go through this later on in the class. What are other ways we could tell the difference between linear and quadratic relationships? Okay, so another way is to do it with a table of values. So here I have the same tables, but we're going to look at pattern 1, which followed the relationship n equals p plus 1. So if I do that here, my p is 3. So that means my n is 3 plus 1, which is 4. And we're going to continue on with all of these. So 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. 7 plus 1 is 8. Now, for some reason, it jumps here, which I don't love, but we'll fill it in anyway. 10 plus 1 is 11, and 12 plus 1 is 13. Now, to find our first differences, remember, you're going to subtract the number on the top from the number on the bottom. So if I go 5 minus 4, I get 1. 6 minus 5 is 1. 7 minus 6 is 1. 8 minus 7 is 1. And because there's a jump here, you can't do it anymore. But notice how all the first differences are 1. If the first differences are the same, then the pattern is linear. Now let's look at pattern 2. n equals p squared plus 1. So p this time is 3 again, but this time we have to square it. So 3 squared is 3 times 3, which is 9. 9 plus 1 is 10. 4 squared is 16, plus 1 is 17. 5 squared is 25, plus 1, 26. 6 squared is 36, plus 1, 37. 7 squared is 49, plus 1 is 50. 10 squared plus 1 is 101. And 12 squared plus 1 is 145. You will get very good at squaring numbers in this class, which is a good skill to have. So now we're going to look at the first differences. Remember, I'm going to do my bottom number minus my top. So if I do 17 minus 10, that's 7. 26 minus 17 is 9. 37 minus 26 is 11. 50 minus 37 is 13. And I'm just going to stop there. These are not the same, are they? Not like they were over here. So this tells me this cannot be linear because the first differences are not the same. We're going to do something new here. Now we're going to take the second differences. This is the same thing. You're just going to subtract 9 minus 7 to find the second difference. So 9 minus 7 is 2. 11 minus 9 is also 2. And 13 minus 11 is 2. So hey, take a look at that. The second differences are the same if it's quadratic. And you know what? I'm going to write that down at the bottom here. So I'm going to add a text box and say if first diffs are the differences, maybe. If first differences are the same, it's linear. Let's correct these. You get to see me. Okay. And it's linear, and at the same time, if second differences are the same, it's quadratic. That's a nice summary. That's something that could be really helpful to learn later on. So I'm going to present that, go through that just to make sure you can see all that. That way, if you come back to these slides, you can see that. Okay, cool. So we looked at what the equations look like between linear and quadratic. Remember, linear just has a letter by itself, and quadratic has a squared on the letter. We've looked at table of values. The first differences are the same for linear. Second differences are the same for quadratic. Let's look at graphs. So if we graphed that table of values, these are the points, and then I drew a straight line through it because linear equations always follow a straight line, don't they? Now, if I graph this other one, check this out. Now, I really should have cut this off to only graph this side, but you can imagine if you have 3 and -3, you're going to get the same value. So that's why it has a mirror. Don't worry about that for now. Okay, so you notice how this p squared plus 1, it kind of increases and it's kind of curved, isn't it? It doesn't go up on a straight line. So this special shape, when we have a p squared in the equation, it's called a parabola. A parabola. Okay? So if you look at these two different graphs, you could tell right away that this one would be linear and this one's quadratic because of their shape. So we're going to look at another pattern, just as the last example. We're going to figure out these patterns and see what step 5 would look like. Well, notice 2 is a 2 by 2 square plus these 4 red ones. Then 3 is a 3 by 3 square plus 4 red ones, and 4 is a 4 by 4 squared plus 4 red ones. So take a think about what step 5 would look like following the same pattern. I'll let you pause it here, and then I'll come back and give you the answer. Okay, so hopefully you figured out that the blue part will be the position number squared. So for the blue one, we will have a 5 by 5 squared, and then the red 4 stays the same, so we'll have a 5 by 5 squared plus 4. So the equation here is position number squared plus 4, and I've color-coded those for you here so it's easier to see. So now we're going to do the table of values. I did the second differences first for you. So I'm going to use my equation and complete this table of values. So 0 squared plus 4 is 4. And then if we continue that, these are the numbers you should get. If you just plug in your p-value for each step. So for example, if we have 2, p squared is 4 plus 4 is 8. And then we're going to do our first differences. So 5 minus 4 is 1. 8 minus 5 is 3. And then we continue onward. And I just kind of stop there because then you get the idea the second differences are all the same. They're all 2's. And if we graph that, it follows a nice parabola again. So good, we've done it right. So that's it for the graphs and that kind of thing. This is a kind of an application problem. So how many tiles would you need for position 12, 20, and 32? And I forgot to do this one, so we'll do this one first. So remember, your position number just goes in for our P in our equation. So for position 32, it's going to be 32 squared plus 4. And if you put 32 times 32 into your calculator, you get 1024 and then plus 4. And so you get 1028 tiles are needed for position 32. So let's go back to do position 12. This time we're going to put 12 in for P. So 12 squared, that's 12 times 12 is 144, plus 4 is 148. And then finally, we're going to do position 20. So now this time P is going to be 20. 20 squared is 400, plus 4 is 404. Okay, so that's it for the lesson. I have 2 other similar problems done out in a practice handout that you can do either online or on paper, whatever you want to do. And I'm going to post the solutions to Brightspace as a PDF as well. At the end, there's a summary chart that I've started filling in for you, and you can complete filling it in as well, and then check with my solutions. Once you've done that and you feel comfortable, there is a little quiz. It's 4 questions using a pattern to answer some questions about it, like what's the equation, what kind of graph would it look like. So you can do that once you feel comfortable. And the next lesson, we'll be talking about more about parabolas and what they look like. Okay, so I think that's it. If you have any questions, let me know. The best way to contact me again is through the envelope in the top right-hand corner on Brightspace. You can either instant message me or you can email. Okay, that's it for today, guys. So I will talk to you next time. Bye-bye.